All right, so hello, Miss Sola here with 2.2. We're going to talk about some converse theorems today. The converse theorems of all the theorems we learned in the last lesson. So yesterday we learned corresponding angles theorem, alternate interior angles theorem, alternate exterior angles theorem, and consecutive interior angles theorem. All of these have a true converse. So this is 2.2 converse theorems. Okay. So for example, my corresponding angles converse theorem. So wordy. Says if if this is my diagram, if these angles are congruent, if corresponding angles are congruent, then the lines are parallel. Similarly with my other ones. The alternate interior angles converse. Sometimes they call it the converse of the alternate interior angles theorem. You put the converse anywhere. The alternate interior angles converse says if these angles are congruent, alternate interior between, then the lines are parallel. Very similarly, the alternate exterior angles converse is flipped, right? If these two angles are congruent, it could also be the two little acute ones. I'm just choosing a random alternate exterior pair. Then the lines are parallel. So the reason this is a converse, remember a converse is something that switches the hypothesis and the conclusion. So the normal alternate interior angle theorem says if the lines are parallel, then the angles are congruent. This just flips it. If the angles are congruent, then the lines are parallel. It's just a converse. And in this last one here, the converse of the consecutive interior, converse of the consecutive or same side interior angle theorem. Ran out of space. I'm not finishing that word. The converse of the consecutive interior angles theorem says if 1 and 2, the measure of angle 1 plus the measure of angle 2 is 180 degrees, then the lines are parallel. Okay? So it's all about taking what we learned in the last lesson and flipping it, and flipping it, and flipping it. Let's see it in a proof. Okay? Let's do a proof. It's been a minute. So I'm going to say, given this diagram, angle 1 is going to be congruent to angle 2. Prove that line L is congruent to line M. And this is what it'll look like. Here's L. Here's M. And label these pretty carefully with me, okay? So this is 1, this is 2, and this is 3. Okay, so This is just the ones that you'll need to use. The angles that I put on the diagram are probably going to be useful, even though we only really know anything about angles 1 and 2. So I've got my statements and my reasons. So for a statement, we're always going to start with what's given. Angle 1 is congruent to angle 2. That is given. There are a lot of ways to complete this proof, a lot of them. It actually could end right now with the converse of the alternate interior angles theorem, but I'm going to do it in a different way just so we can get there in a different way. I think it's really important to take a moment before you start a proof and like form some kind of a plan. So my plan is to use the corresponding angles converse because they gave me a 3 and I'm noticing that 3 is congruent. 3 and 2 are corresponding. So if I can prove that 2 and 3 are congruent, then I can prove that these lines are congruent. So let's do the next one. Step 2. So how can I relate either 1 or 2 to 3? I can say that angle 1 is congruent to angle 3 because they are vertical. Vertical angles theorem. Because they're vertical, that means they are equal, congruent. Step 3, let's say angle 2 is congruent to angle 3. I'd say 2 different choices for my reasoning here. Notice from step 2 to step 3, the 1 just changed to a 2 because they're equal. I can replace one with the other. So it'd be substitution. Or 1 is congruent to 2, or 2 is congruent to 1, and 1 is congruent to 3. So 3 is congruent to 2. This could also be the transitive property here. Going through that flow. Now, once I've got this, 2 is congruent to 3, then I know L is parallel to M because of the corresponding angles converse here. Corresponding angles converse. The one that flips it in reverse. If they're congruent, then it's parallel. All right, and we're going to do one last proof to finish it off. Ooh, this is going to be tight. Okay. Given angle 1 is congruent to angle 3 and R is parallel to S, prove P is parallel to Q. So I'm going to have 2 sets of lines here. R, S, these are parallel, proven, given, done. And then I'm going to go P and Q, okay? And then my angles here are 1, 2, and 3. Oof. Okay, I know that 1 is congruent to 3. Prove that P is congruent to 2. Okay, so looking at this, the only thing that I know, I'm going to make a plan. The only thing I know relating P to Q is this 3 and 2 relationship. And notice that these two are alternate exterior because they're outside. They're not between P and Q, and they're on either side of the line. So when I make my proof over here, let me make it kind of like that. Okay. When I make my proof over here, my statements and my reasons, I'm going to start with the given. So 1 is congruent to 3, and R is parallel to S, given. Because R is parallel to S, then I know 1 is congruent to 2. 1 is congruent to 2. And this is just because those are corresponding angles. these two are corresponding angles, so I know they are congruent. And I already knew that 1 is congruent to 3. So can I say that angle 2 is congruent to angle 3? My gosh, following a very similar pattern. I should have used different numbers. You can, again, use substitution, or I like transitive for something like this because it's kind of flowing through the 3 sentences of this. And because we have now proven that 2 is congruent to 3, now P is parallel to Q because of the alternate exterior angle converse. Alternate exterior angle converse. That says if these two are congruent, then the lines are parallel.